You always wanted to know how to pass arrays to SQL Server. Watch this ultimate guide on table-valued parameters. Hello and welcome! My name is Vedran Kesagic. I'm a Microsoft Certified Master for SQL Server, and this video is absolute must if you are a developer dealing with databases. Everyone wants fast databases, and a way to achieve that is through passing a set of data, not one by one. So we need a way to pass an array of rows into SQL Server at once in a single SQL command. That is not the same as passing 1,000 SQL commands with single row commands. That is single row processing known as RBAR. We don't want to do that. We want to do a single command with thousands of rows. How to do this? This will become your basic building block of your application, and it is a must if you want good performance of data processing. So if we want a fast performance, set processing is essential. That means we will deal with sets, not with rows. And we will learn how to send a set to the database. That is essential, basically. So let's begin with a simple task. We have a big table, let's say 30 million rows, maybe bigger, but for this demo it's just 30 millions. It has identity and the status. Very simple table. And what is the task? The task is to update the status column to something else for a certain set of rows. Let's say 30,000 rows. We need to update. Of course, this is only example. Update is only for example. It could be any other SQL command like insert, delete, select, merge. It can be a stored procedure you call, and you want that procedure, stored procedure, to process 30,000 rows. Any SQL command. Update is just example. Same technique applies to any command. We will go evolutionary approach. That means we will start as beginner and with the worst possible solution, and we will evolve to a better one until we reach the best solution. So bear with me. First and the worst practice is to build a comma-separated list of values and send that to SQL. It looks like this. Update my table set status equals 123 where ID in, and you build this comma-separated list with baked-in values. Dynamically you build it. Or you can use another variation of the same, which is OR list. So you put the values with OR condition, but it is essentially the same. Effect is essentially the same. Telltale sign is this comma. If you use comma to separate the values, or you use OR to list the values, then you are using the worst possible method. So why is this so bad? Why is this comma-separated value bad? SQL has so-called plan cache, which is an amazing thing that can speed up your queries. Every cache is there to somehow improve performance, including this cache. That means when query comes to SQL, it needs to be optimized. SQL needs to produce execution plan which is the best for that query, or good enough plan. And that process is called compiling, optimization and compiling the SQL statement. And that compiling takes a lot of CPU time, and it takes certain locks. And that locks block other users. And CPU time is precious and adds up to your query. So you don't want to waste any more CPU time if that query repeats. That's why it is compiled once. A result of the compilation execution plan is cached into plan cache, and then when the same query reappears, that plan is reused immediately. We skip compilation. But if we list comma-separated values, every time query comes, it's a bit different because values change and the number of values change. So every time the query is different. and that cache cannot be reused. That cache is reused only if command execution comes with identical command, no different values, etc. So we need something different, something to use that plan cache. And how will we fix that? We will use parameters. We will introduce parameters. So we will send our values not directly baked into SQL command, into SQL statement. We will separate the values from the command by using parameters. That looks like this. Imagine this status, it's a variable here, but imagine it's a parameter, input parameter, and we will have ID1, ID2, etc. And our command will look like this: update table set status equal new status, where ID in, and you will just list these IDs, but they are now parameters. So one might think, wow, we solved it, finally. Every time command executes, it will be able to reuse the plan, but it won't. Why? Because the number of parameters is variable, and it can very much vary, and therefore you get tons of plans in the cache and you never reuse them. You seldom reuse them, and that's really not helping anything, not helping much. And that means we have weak reuse of the plan cache. Still we use CPU for compilation, extra overhead of CPU. We introduce compile locks and block other sessions. We are flooding the plan cache still. But it is SQL injection safe, because when you use variables, parameters, that is safe from SQL injection attacks. So we got one green checkmark more. Still, performance is very slow. It doesn't scale because of these blocks, compile locks. It doesn't scale. When you execute with multiple threads, you get basically execution speed as one thread. So you don't get anything with multiple threads or minimal gain. It's slow, super slow. Don't use it. And by the way, some frameworks like Entity Framework often generates this query. If you rely on code, SQL code that is generated by some framework, don't expect good performance, because auto-generated SQL is bad. It's like worst developer ever. Auto-generated code is like a collection of bad practices that perform poorly. It works well only with super small databases, small number of users. I wouldn't recommend it to a serious system. Only if you have a small database and low number of users, you don't care about performance, you use Entity Framework. Otherwise, you need to code your SQL statement. You need to learn SQL. If you want to be a good developer that deals with databases, you need to learn SQL language, and there is no way around it. You need to code your own SQL. That will give you the best possible performance. Don't rely on ORM for that. At least some parts you need to code, the slowest one, the ones that need good performance. So please, learn SQL. How to fix this? This number of parameters, this variation in number of parameters. We will use single parameter, which will be comma-separated value string, or XML value, one XML value with many IDs inside, or JSON, one JSON string with many values inside. So that's the one parameter. It looks like this: ID list equals, so this is one string, and we have update command set status equals where ID in, and then you have this ID list as a string, and you need to somehow convert it to a table, parse that string, convert it to a table to be able to use this comparison. And that can be with CSV, it's string split, but if it is XML, you have nodes function. With JSON, you have open JSON function. But every of these function uses CPU time, and a lot of CPU time. If array is big, it's substantial CPU time, and it's slow because of that. It eats up your CPU and it doesn't perform well. But It's better than previous methods. Why? Because finally we are reusing the plan cache, because every time we have identical query, even if we change the values, even if we change number of values, we always pass one parameter, and it doesn't matter what values are inside, it will always be reused. That plan will be reused. So we are in good situation. We are using plan cache, no more recompile CPU, no more compilation locks. We are not flooding the plan cache with thousands of different plans which are never reused. And it's SQL injection safe, but we lost one checkmark. We lost the checkmark which parses this array. That means we spend extra CPU on parsing that array, and that's why the performance is still not good. It's slow performance, but it's better than previous two. So we evolved a bit. So let's see how we can improve that, how we can skip that parsing time. Table valued parameters. Whoa, finally, to something really good. First to be said, every popular framework supports table valued parameters. And that's old technology, like 15 years old, and everybody should be aware of it and use it on a daily basis if you deal with databases. It works well even with entity framework. Performance is great. If your query is not too complex, this part of passing array, thousands of values, this works flawless. It requires a bit of preparation, which is a type. We need to create a type inside the database. That type is array type, table type. And it is best practice to name it according to data type, because we want to reuse that type. We want it to be reusable. If you call it like, for example, person collection, then you will be able to use it only on person table. But if you call it just integer collection or integer array or integer list or integer table, never mind, then you can reuse it everywhere where you have list of integers. Everywhere. It's super reusable. You don't have to create hundreds of types inside the database. You create only one type for integers. You can create more complex type like integer and string, integer and date. But this is the basic one, and this is the demo. How it looks? It looks like this. This part is here declaration of variables, but when you pass variable from .NET as a parameter, then it's a parameter. It's not a variable. Value comes into this parameter. So we declare IDs as a collection, int collection. It's a table valued parameter. And we insert the values there, thousands of values, for example. And then we have update command, update status from table where MID in, select int value from IDs. So why this is good? Because we don't have parsing time anymore. We don't convert from some string or XML or JSON into table. We have table already there. No parsing, no conversion. It's direct usage of these thousands of values. Let's see comparison. We have all the benefits as before, but we avoided string parsing. Wow. And also it scales well. If you use multiple threads, it will scale well until you hit some point when a lot of locks occur and you cannot, with increasing more threads, you cannot anymore increase the throughput, or you hit some other bottleneck. So it is okay, but if you, for example, update a lot of rows at once, let's say 10,000, it will not scale. It will lock entire table and it will not scale. So we have something better, something even better. This is very fast, super efficient, very fast, very good method. But let's see how to improve even that. Table value parameters has two problems. First one is, if you insert more than 10,000 rows inside, for some reason it performs bad. I don't know exact reason, but I measured it, I experienced that, so I keep my table variables, table parameters up to 10,000 rows. And if you change more than 5,000 rows at once with a single command, let's say update or delete or insert, if you change with single command more than 5,000 rows, it is very likely that lock escalation will occur. That means entire table will become locked and all other users on the database will be blocked, which want to access this table, which want to change this table. And that is called lock escalation. You maybe remember if you ever tried to delete a lot of rows with a single command, then it blocked all other users. They call you, what is happening? We cannot work. Everything is blocked. Why we cannot work? Well, that's called lock escalation. And to avoid it, it's best to use up to 5,000 rows. Let's say with 4,000 rows, it is safe. I mean, this limit is a little fluid. It's not fixed 5,000. It can be more, it can be less, but usually it is more. And depends on situation of the server. And you are quite safe. If you are below 5,000, you are quite safe that it probably, it's very unlikely to occur if you keep less than 5,000 rows. So what can you do to solve both problems? TVP with batches. And another thing we will use, because we created that type, this table type with primary key on the value, that means value is unique. And we can use direct join with that table valued parameter without introducing duplicates. We ensure that, we guarantee that with this primary key. And that's why our statement is even simpler. Direct join on that value. No conversion, no anything. How cool is that? The best solution is also simple, simplest one. And we need to pass up to 5,000 rows per execution. And we loop until we finish. And let's see the full comparison of methods. TVP with batches has all the benefits, but it also doesn't lock entire table. We don't have that lock escalation issue anymore because we are below this threshold in a single command, in a batch. And we never lock entire table. That means we can use multiple sessions in parallel, and we won't lock the table. We will get increased speed. Even if we want to update, let's say, 1,000,000 rows, they will go iteratively, 5,000 or 4,000 by 4,000, and they will never lock the table, and it will be super fast performance that scales, super scales. And it is injection safe, all the benefits of other methods, plus super scalability. Great, great thing. Very fast, recommended, warmly recommended. Now is the time for the demo. Let's see how it works in the .NET code. I prepared here code for you. We are using a Microsoft Data SQL client. That's a new ADO.NET library for SQL client, and old one was very similar, system.data. So you don't need to change your code. You just change this using from system to Microsoft, and you're done. That's it. It doesn't have full features as previous library, but it's developing and it is very close. And all the new features will be there in this Microsoft Data SQL client, not with the old one. So for new development, it's recommended. Here is our main part of the program. We have IDs, array of IDs filled as data table. So we create a new data table object and we add one column. It doesn't need to match with the name to a table type, but it needs to match with the type and number of columns. We then fill 30,000 rows into that data table, and then we are ready. We open the connection, new SQL connection, we open that connection, and then first it's just an example of select, simple select. So we are creating new SQL command, select blah 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 from sysobjects. It's just for demo how to do select. Command.parameters add date. Date is of type datetime2, and then we set the value to current time. And the benefit of that is we are injection safe, and we don't need to care about conversion or locales of different languages. We don't care about converting to string. We stay with native types, native .NET types and native SQL types. They match. And you always specify a date type. Don't ever rely on automatic type detection. That always generates some problems. I won't explain it here, not to be too broad, but that's why you need to avoid add with value. Use this plain parameters add, specify explicit type, and assign a value. And then you need to load the result, which is also some result of select is also data table. So we create that data table, and we execute that command with execute reader, and we load that reader into data table, resulting data table. And we are done. What is the name of the first row and how many rows are processed. So first row, it's 0 based, and then first column of the first row. We just one return, we don't want to return all the rows. So let's run that, F5, execute. So it is opening a connection, and connection is opened. So let's continue, F5. Now we're done. Super fast. This select was executed. You see how it looks? This is not a direct value, it's a parameter. That's why it is reused on every execution. Even if you change the date, the command is always the same, because we use parameter, not actual value. We are not using plus or concatenation. We are using parameters and send the value as a value of the parameter. That's why it is reused. 75 characters, and it's instant, 108 rows it retrieved. Let's go to the first scenario. We are using our update command, set the status to some random value, var id in, and then we use the worst approach, the worst case scenario. That is listing IDs with comma. Don't ever do that. So we are building our list of IDs, list of values with comma, and then we are finishing it with close parentheses. And let's see how that performs. We will stopwatch that. We will measure the time and see elapsed time. Let's see, run. So running. See, this is the command. Oh, almost 5 seconds, you see? 5 seconds. So you see the command, it's huge. Even scrolling through that, it's enormous. It's really enormous. You may say that's first execution, but even if I rerun that, it's always the same, trust me. I can rerun it, but video will be longer. Just, it's the same, always the same. Let's see the solution with table valued parameters. Again, we build our update command, update set status from table, join IDs, because they are unique, they have primary key, so they are unique, we can directly join without introducing duplicates, and we set parameter status, which is type int, we set the value to some random value, and then we have interesting part, we use a table valued parameter here, and the type for that is structured. It's called structured, and the value is our data table IDs. That's our data table, and we assign the values like that. We need to specify a table type we used, database table type that it will match. So we say that parameter dot type name equals and the name of the type. And then we measure the time again, execute it, and that update will update 30,000 rows and see how fast it is. So almost 5,000 milliseconds was with comma separated values. Let's see. Start. Go, finished. You see? 92 milliseconds. So it is 100, let's say 50 times faster. Why is that 50 times faster? Because we are using table valued parameters. We are skipping compilation, parsing, locks. We are skipping everything. We just use the compiled plan in the cache because I ran it already. And even compilation is simple because the string is short. You see how long this command is. SQL command 200,000 characters. And I've seen that regularly if you use some ORM like Entity Framework, it will generate 200 kilobytes of SQL. Enormous, long, bad written query like this if you don't use table value parameters. And you see how faster it is? 50 times on the same machine. And it scales. If I would use multiple threads, I would get even faster speed. But with these comma separated values, I wouldn't get faster speed. Marginally. Nothing. But with this table valued parameters, it's simpler and it's much faster and it scales with multiple threads. So let's go back. Now a bit advanced for the ones who want to know more. Table valued parameters with dynamic SQL. We will solve a situation that I call optional filters. Optional filters is a situation when you have a condition that can be turned on or off. For example, you say, give me person with this ID, or if I don't specify ID, give me all persons. Or give me telephone number with this telephone number, or all numbers if I don't specify this criteria. It's like switching on or off different criteria. And how people usually solve this? They use statement like this. In where clause they put and column name equals parameter, or parameter is null. If parameter is null, that means give me all rows. Or another variant, they can use is null or similar. You see the column on both sides of equality or inequality. And what it does is basically the same. If this parameter is not specified, you get column equals column, that means all rows. And if this parameter is specified, some value, then it will give you only the rows that satisfy column equals that value. That's what you want. Functionality is good, but performance is not good. Why is not good? Because essentially what we want to use, if we have index on that column, we want that index to be used if we specified that value. If you specified the value of the parameter, you want to use index on that column to quickly find that value and get out. So that's what you want, index seek. If you don't specify a value, using an index to pick a row one by one is very inefficient because you always have extra reads from the root of the tree to the bottom. It's super slow. It's much faster to scan entire index. And that's what you want if you don't specify the index. But the trouble is, SQL can have only one plan per SQL command. And that plan must be broad, must include both cases. And which plan is wider one that includes all the cases? Full scan one, exactly. So the plan SQL will choose, and it's logically the only one he can choose, is full scan. And full scan is bad for this picking of single rows. Full scan performs really, really bad, especially if you have huge tables. It's catastrophic. It doesn't perform. And how to solve this efficiently inside of SQL? Well, first, let's see what people usually do. They say, okay, my optional parameter is array. And I want to say, if that array is empty, give me all the rows. if I have values in that array, give me only these rows, which I specified. So we have this array, IDs, type of int collection, and we update the status where ID is in this array. But if this array is empty, this wouldn't give me all rows. This wouldn't update all the rows. It would update 0 rows. So I need to add this, or if this is empty, give me all the rows, or update all the rows. And this or is a telltale sign of bad performance. Whenever you have or, SQL will come up with a broader plan, which is a full scan, bad performing plan. And how to solve that? With dynamic SQL. How that looks? That looks like this. The same, you have the same parameters here, but command, we are building a command. And that command includes this join with IDs and minus minus in front of them and some token. Minus minus some token, minus minus. It's just a token that is actually comment out. It will comment out this line. It will put it out of effect. It is commented out. And that means update all the rows. If it is executed like this, it will update all the rows. And therefore, we are testing in the code, do we have any rows inside? If yes, we will remove this minus minus tag. We will remove it. We will replace it with empty string. That will effectively delete this minus minus IDS minus minus, and this join will be in effect. This filter will be in effect. This basically says, if I have some IDs values in the array, put the filter in effect. If I don't have any value in the array, keep it commented out. I don't have that filter applied. And then I execute that SQL with parameters. And one of the parameters is our array. And even if I don't use it, even if this is commented out, it will not throw error. I still am passing that parameter, which is empty, doesn't take much space, almost none space, and it won't throw error. It executes well. And each time you get perfect plan, because you have different statements for two combinations, once commented out, once without commenting out, and each statement gets separate plan, one with index seek, one with index scan, and then it's perfect. It performs perfect every time. And if you have multiple these conditions, number of this combination can be high, but what is used is usually low. Let's say 10 combinations out of possible 100 are used, and then you have 10 plans in the cache, and each plan is perfect for that combination of parameters. You always get super good performance. It's brilliant. It works beautiful. And this is final comparison. So don't use comma-separated values. Don't use OR lists. Don't use entity frameworks for stuff that you care about performance. Or if you use it, you need to apply certain techniques to avoid slow performance, like write these parts in stored procedure, or some other techniques. I'm an optimization expert and can help you with that. So thank you very much. You're welcome to visit my blog, to contact me for any SQL Server assistance, for trainings. And thank you very much, and see you in the next video. Bye bye.